Welcome to Get Your FRQ On. This question is from 2018. It's question 3, and it is not calculator active. In the question stem, we have the graph of a function, which is mostly line segments, but part of it is quadratic. These parts are defined in the question stem itself. In part A of this question, if f of 1 is equal to 3, we are asked to find the value of f of negative 5. The value of f of negative 5 can be found by evaluating the definite integral. F of negative 5 is f of 1 plus the integral from 1 to negative 5 of g of x dx, which is 3 minus the integral from negative 5 to 1 of g of x dx. So f of negative 5 is 3 minus the integral from negative 5 to 1 of g of x dx, which is 3 minus negative 9 minus 1.5 plus 1, which is 3 minus negative 9.5, which is 12.5. In part B of this question, we are asked to find the integral from 1 to 6 of g of x dx. The integral from 1 to 6 of g of x dx is the integral from 1 to 3 of g of x dx plus the integral from 3 to 6 of g of x dx. The integral from 1 to 6 of g of x dx is 4 plus the integral from 3 to 6 of 2 times x minus 4 squared dx, which is going to be 4 plus 2/3 of x minus 4 cubed evaluated between 6 and 3. So the integral from 1 to 6 of g of x dx is 4 plus 16/3 plus 2/3, which turns out to be exactly 10. In part C of this question, for values of x between negative 5 and 6, what open intervals is f both increasing and concave up? And make sure that you provide a reason. So f will be increasing when f prime of x, which is equal to g of x, is greater than 0. Based on the graph of f prime of x equals g of x, f of x is going to be increasing on the interval from 0 to 6. And f is going to be concave up when the second derivative of f, which is g prime of x, is greater than 0. That is, when f prime of x equals g of x is increasing. So based on the graph of f prime of x equals g of x is increasing on the interval from negative 2 to negative 1, again on the interval from 0 to 1, and again on the interval from 4 to 6. Therefore, we can conclude that f is going to be both increasing and concave up on the interval from 0 to 1 and on the interval from 4 to 6. In part D of this question, we are asked to find the x-coordinate of each point of inflection of the function f and to provide reasons. So f will have a point of inflection whenever the second derivative of f, which is equal to the first derivative of g, is equal to 0 and also changes sign. That is, whenever g of x has a relative maximum or relative minimum. Based on the graph of f prime of x equals g of x has a relative maximum nowhere and a relative minimum only at x equals 4. Therefore, f has a point of inflection at x equals 4. If you want more AP Calculus AB free response question solutions, don't forget to like this video and subscribe to my channel. You can also follow me on X at x.com/. slash get your FRQ on.